Yeah, sorry for that interruption. We are about to end our lesson. I think I may be forced not to go into X-rays, but let me try to wind up. The condition under which this reaction occurs are: 1, the temperatures must be low. We need low temperatures. We need low temperatures, and we need fast moving neutrons. In other words, we need a neutron. A neutron is a must have. The applications, where do we apply? Applications of fission, nuclear fission. Since we are saying it is a massive decay to lighter objects, it means it is used in making of atomic bombs. That's why bombs, missiles are able to destroy a bigger space. It is also used in generation of electricity, especially nuclear electricity, of nuclear power, which you can call electricity. And can also be used in the generation of heat energy on large scale. Generation of heat energy on a large scale. This is detailed information that you may not ordinarily get from all your classrooms. We look at nuclear fusion and we come to the end of our lesson. We have already defined nuclear fusion as the union or the combining of two lighter nuclei to produce a heavy nucleus, but in the process some energy is released. And we'll look at an example of a nuclear fusion. Since we have the definition, example of the equation, of the format of a nuclear equation. Now here we are combining, especially we use hydrogen. We use hydrogen, we can use 2 hydrogen plus 2 hydrogen. We'll combine to give us helium plus a neutron plus energy. This is a typical equation of a fusion kind. That you are combining 2 lighter deuterium. Deuterium is a heavy hydrogen atom. This is 21H. Is what we call deuterium, heavy hydrogen. We know hydrogen is the lightest gas from your chemistry. So when 2 deuterium nuclei combine at very high temperature of about 100 million Kelvin, they give us a fusion reaction with the release of energy as indicated. And we are saying reactions of this kind occur in the sun and stars. Sometimes they ask you to give examples of nuclear fusion. The sun and the stars, other stars. I hope you are aware as physics students that the sun is a star. And it is the biggest star. And we are saying the fusion reaction occurs in the sun and stars, and these are the source of the sun's or the star's energy. Reactions of the kind of the nuclear fusion are the source of the energy that we obtain in form of light from the sun and from the stars. Conditions for them to occur: Conditions for a fission reaction in an outlined form. Very high temperatures. One will use hydrogen used to produce hydrogen. Conditions. Under the conditions, we say we must have hydrogen use. Temperatures are very high temperatures, and use of lighter nuclei at a very high speed. Lighter nuclei at high speeds. Applications. Where are they used? Of nuclear fusion. Applications of nuclear fusion in the production of hydrogen. In the production of hydrogen, in the making of atomic bombs, in generation of electricity. They are all nuclear reactors. And also in the generation of heat energy on a large scale, just like for the nuclear fission. What are the similarities between fusion and fission? Usually the question that can be asked, distinguish. Distinguish looks at the difference. Distinguish between fusion and fission. If they ask you to distinguish, one of the distinctions will be their definitions. You distinguish the two by defining that this is the splitting of a heavy, the other one is the joining of two lighter, and you continue and finish. But they can ask you to distinguish between the two. You can still say that for a fission reaction, you bombard it with a neutron, whereas a fusion requires combining of deuterium or heavy hydrogen nuclei. What is the difference between fusion and fission? In the difference, I'm emphasizing that the definition is very key. One requires low temperatures, the other one requires high. The other one will require a neutron, the other one does not require a neutron to start. And in the differences, those are differences. They can ask you the similarities. The similarities are that in both reactions, we have release of energy. Two, they can all be used in the generation of power and in production of atomic bombs. Those are similarities. And ideally, there is energy release and energy change, and they can all be used in nuclear power generation and also manufacture of atomic bombs. Differences, I've said, talk about the definitions. Talk about how the fission requires low energy while the fusion requires high energy, high temperature. Talk about how the fission requires slow neutron for bombardment, and while the fusion does not require any neutron at all. Talk about how energy is released, very high energy, about how low energy is released in fusion, and as per the equation, the fusion results into helium and a neutron, and the fission gives us two products. It gives us barium, krypton, and two neutrons. Once you understand those, then I will think you'll be good to go. Because of what I have shared, I think that is enough for us to generate our exercises for today. When we meet next and we are dealing with physics, we shall look at X-rays. I want to bring this lesson to the end. And once again, continue to encourage you to like the page. Tell a friend that these lessons are real. And if you want specialized attention beyond here, like marking of the exercises I'm talking about, then you must inbox me so that there is some small remuneration towards the teacher. Thank you. God bless you for God and my country.